Problem number 2. The figure shows 3 layers of soil in a tube that is 100 millimeter by 100 millimeter. That is its area in a cross section. Water is supplied to maintain a constant head difference of 300 mm across the sample. The hydraulic conductivities of these soils in the direction of the flow to them as follows. So we have to find the rate of water supply in cubic centimeters per hour, and for our K in soil A, that is equal to 10 to the power of negative 2 centimeter per second. And for our soil B, the second layer, it is equal to 3 times 10 to the power of negative 3 centimeters per second. And for our soil C, that is 4.9 times 10 to the power of negative 4 centimeter per second.
You can see in the figure, we have 3 layers of soil, A, B, and C, which is each have a length of 150 millimeters, and the total length is 150 plus 150 plus 150 is 450 millimeters. So it is also given with a constant head difference of 300 millimeters. So first is we will write down the given. A is equal to 100 by 100 millimeter squared, and our length for A is equal to length for B. It is also equal for length for C, which is 150 millimeters, and for our total length, that is 150 times 3, which is 450 millimeters, and a constant head difference of 300 millimeters. The same formula, Q is equal to K IA, but in this problem, we will be solving for I, and A is given. We are also asked to solve for K, and then substitute the value for A, I, and K to our formula to solve for the rate of water supply in cubic centimeter per hour. So the solution is for I, it is equal to the constant head difference over the total length. We need to substitute its values. We have the value for the constant head difference, 300, divide L, 450, that is equal to 2/3. Second is for K. For the series flow, we use KV equivalent. The formula for that is L over HA over KA plus HB over KB plus HB over that is HC over KC. For K equivalent, that is equal to 450 over 150 over 10 to the power of negative 2. That is the from the given table values, plus 150 over 3 times 10 to the power of negative 3 plus 150 over 4.9 times 10 to the power of negative 4. So solving that, we will get the KV equivalent, which is equal to 0.001213 centimeter per second. So since we now have the value for I and K, we will solve for the value for A. That is just 100 by 100 millimeters. In order to convert that, we need to divide it to 10 squared to convert it to centimeter squared. So A now is 100 centimeter squared, I is 2/3, K equivalent is 0.001213 centimeter per second. We just need to substitute the values. Q is equal to 0.001213 times 2/3 times 100. Since we have here a centimeter cube per second and we are asked the rate per hour, we just need to multiply it by 360 to convert into hour, and now Q is equal to 291 centimeter cube per hour.